So, sir, if you were there in the last class, na, inverse trigonometry, which we were doing. Hello. Hello, Sharif. Can you
Yes, sir.
hear me? You were there in the last class?
Yes, sir.
Sorry, I can't get you. You become mute again.
Yeah, I was in the last class.
Okay. So, in CBSE class, what is going on right now?
Inverse trigonometric functions, properties of IT.
Properties of?
Inverse trigonometric functions.
Okay, okay, fine. So, we will be doing a few identities of inverse trigonometric function today, which are important with the concept of JEE. So the first identity is that tan inverse x plus tan inverse of y is equal to. Now there are cases here okay, Shavaz is also joining. Okay, so tan inverse x plus tan inverse of y is tan inverse of x plus y by 1 minus xy. But it is not so always. It is true.
Sir,
Yeah,
this is the first property you are discussing.
yeah, this is the first identity. I just started. Okay.
Yes, sir.
So this is if xy is less than 1. This would be if and x is positive and y is positive. That is, of course, there. That is, we are taking x positive, y positive, and xy is less than 1. Then we have x positive, y positive, and xy greater than 1. So we have in that situation, the identity becomes, it becomes pi plus tan inverse of x plus y by 1 minus xy. So why there is a change like this, we will discuss it right now. So if this xy is less than 1, it is like this. And if xy is greater than 1, it becomes like this. So there is an important concept behind it. So if we try to prove this, because proofs are very important in inverse trigonometry because they all involve the concept of principal values. And principal value is the backbone of inverse trigonometric function. So if you see the conditions of principal value, then you will be able to understand many questions. So here, if we try to prove it, that let tan inverse of x is equal to alpha and tan inverse of y is equal to beta. And since we are taking x positive and y positive, so what it means, sorry. So if you take tan inverse x is equal to alpha and tan inverse of y is equal to beta, then in that case, since xy we are taking positive in both of them, we are taking x positive, y positive here also and here also. So tan inverse x will give you alpha, which will belong to 0, pi by 2. And tan inverse y will give you beta, which will belong to 0, pi by 2. So this is the condition here. That is, alpha is 0 to pi by 2 and beta is 0 to pi by 2.
Sir, the principal value of tan is 0 to pi, right? Sorry, minus pi by 2 to pi by 2.
Principal value of tan is minus pi by 2 to pi by 2. But since we are taking positive value of x is greater than 0. So it is only 0 to pi by 2. Because if x is negative, then we will get minus pi by 2 to 0. Actually, the principal value is minus pi by 2 to pi by 2, but we are only taking positive values of x. So we are taking 0 to pi by 2, and similarly positive values of y. So we are taking 0 to pi by 2. Okay.
Yes, sir.
Okay. Now what we can do, we can write it as x is equal to tan alpha, and here y is equal to tan beta. And then what we will do is, we will apply a formula of trigonometry, which we studied in class 11. Tan alpha plus beta is equal to tan alpha plus tan beta by 1 minus tan alpha into tan beta. Tan alpha is x, tan beta is y. This is like this. Here there is no issue, there is no complication till here. I will let you write also. First, let us see how we are doing it. So next is this tan has to be taken on that side. That means we apply tan inverse. Tan of alpha plus beta is equal to tan inverse of x plus y by 1 minus xy, both the sides. Now the real challenge comes. Can we cancel this tan inverse and tan and write it as alpha plus beta, or we can't? Can anyone tell? See, alpha is 0 to pi by 2. Beta is also 0 to pi by 2. So if we add alpha plus beta, its minimum value will be 0 and maximum value will be pi by 2 plus pi by 2, that is pi. Okay.
There should be minus, like if you want to cut it.
See, alpha plus beta is 0 to pi. Is this the principal value range of tan? No. Correct. So this is not the principal value of range. But 0 to pi by 2 is the principal value of range. So we will take two cases. Case number 1, that alpha plus beta is between 0 to pi by 2. And another case, that alpha plus beta is pi by 2 to pi. There will be two different situations. So first write till here, from here. Then we will see what we can do further. Have you written till here?
Yes, sir.
Is written? Written? Should we proceed?
Yes, sir.
Okay. Now, if it is 0 to pi by 2, then in that case, tan inverse and tan will be a straightforward cancelled, and we will say that alpha plus beta is equal to tan inverse of x plus y by 1 minus xy. And if it is between pi by 2 to pi, then we will write first, it is tan inverse of tan, and alpha plus beta will be written as alpha plus beta minus pi is equal to tan inverse of plus y by 1 minus xy. This we can do because tan of theta minus pi is tan theta. You can remember this. We used to do this like this. No? If there is tan of theta minus pi, which means minus sign taken common and comes outside. So minus tan pi minus theta, and tan pi minus theta is minus tan theta. So this will be plus tan theta. So using this concept, we can write it like this. Now, if alpha plus beta minus pi we see, what will be its interval? Alpha plus beta is pi by 2 to pi. So alpha plus beta minus pi will be pi minus pi 0, and pi by 2 minus pi is minus pi by 2. So it will become here minus pi by 2 and here 0. So this is, yes, the principal value range of tan, that is minus pi by 2 to 0, because minus pi by 2 to pi by 2 is the principal value, and this is a part of it, is a subset of it. So it is lies in principal value region. So we can write alpha plus beta minus pi is equal to, we can cancel tan inverse and tan, x plus y by 1 minus xy. So this will give you alpha plus beta is equal to pi plus tan inverse of x plus y by 1 minus xy. So this is alpha plus beta. Now,
Just scroll up.
Sorry.
Just scroll up.
Yeah, I will scroll up. I will give you the time to write. So tan inverse x plus tan inverse y is equal to pi plus tan inverse of x plus y by 1 minus y. Now, first write till here. One work is still remaining. That is, we have taken alpha plus beta, the condition on alpha plus beta. But that condition should be reflected in terms of x and y, because alpha and beta we assumed We assume that x is tan alpha or tan inverse x is alpha, tan inverse y is beta. Actual condition in the formula is on x and y. So how we can change this condition, which is on alpha beta into xy, that we will see now. So first write this one, starting from here. Till here you have written. Now you can write from here. I hope you have written till here. So I'm scrolling it down. So now the point is this alpha beta condition, this is also tan inverse of x, alpha is tan inverse x, beta is tan inverse y. So it is equal to tan inverse of x plus y by 1 minus x1. So till here it is okay that we have got two different formula. One formula is this and another formula is this. But when to apply this formula? Because we don't have alpha beta here, we have x and y. So when will we apply this formula and when we will apply this formula? So for that, what we have to see that alpha plus beta is between 0 to pi by 2. Now, if see it carefully, if alpha plus beta is between 0 to pi by 2, so that means that tan inverse of x plus tan inverse of y is between 0 to pi by 2. This we know that x and y are positive. So that is why tan inverse x plus tan inverse y is greater than 0. Another condition is that tan inverse of x plus tan inverse of y is less than pi by 2. Now this condition, how to deal with? So we will write tan inverse of x less than pi by 2 minus tan inverse of y. And we have done this property that pi by 2 minus tan inverse of theta or tan inverse of y, whatever it is cot inverse y. We have done this property. And further, we have also done this property that cot inverse of y is tan inverse of 1 by y if y is a positive quantity. And here we are taking x and y as positive. So this is what we have, which means if we remove tan inverse, x is less than 1 by y. So xy is less than 1. So this is how the condition on alpha beta changes to the condition on xy. So we say that this tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. When xy is less than 1 and also x positive, y positive, because we are taking alpha beta greater than 0. Tan inverse x, tan inverse y.
Sure.
Yeah.
Can just explain this part once more.
Yeah. Actually, we took alpha plus beta between 0 to pi by 2, right? So now what is alpha and what is beta? Alpha is tan inverse of x and beta is tan inverse of y. Okay. So this is what we are having. Now, tan inverse of x, since tan inverse x and tan inverse y both are positive, so their sum is going to be positive. Another, that is x and y are positive, that we have written here. Another condition is tan inverse x plus tan inverse y is less than pi by 2. So from here we will write tan inverse x is less than pi by 2 minus tan inverse y, which will give you tan inverse x less than cot inverse y, because pi by 2 minus tan inverse y is cot inverse y, because tan inverse y plus cot inverse y is pi by 2. Have you studied this property?
Yes, sir.
Yeah. So this is another property is cot inverse y is tan inverse 1 by y if y is positive. So here we are taking y as positive. If y is negative, then it is not written like this. Then there is some change, a small change. But here y is positive. Now we remove tan inverse from both the sides because it is an increasing function. So x becomes less than 1 by y, which means xy is less than 1. So this is the condition which was written here, x greater than 0, y greater than 0, and xy less than 1. So this is the condition which we are getting for this formula. So first write this condition, derivation of this condition. I think you have written till here. This last two steps also you write it. Alpha plus beta between pi by 2 to pi. This is the next for this formula. So if alpha plus beta, which is tan inverse x plus tan inverse y, is pi by 2 to pi, so smaller than pi it is okay, because we know that tan inverse x, which is alpha, is 0 to pi by 2, and tan inverse y, which is beta, is 0 to pi by 2. So if we will add the upper limit, it will be pi. But what about its lower limit? So pi by 2 is less than tan inverse of x plus tan inverse of y. We can write it like this. Now, pi by 2 minus tan inverse of y, as we did there also, is tan inverse of x. This will become cot inverse of y is less than tan inverse of x. And so, tan inverse of 1 by y is less than tan inverse of x. So what it means now is that 1 by y is less than x, or we say 1 is less than xy, or we write it like this, xy greater than 1. So this is another condition, and x positive, y positive is the condition which is already there. So these two formula comes with these conditions. There are many formulas, conditions, and all, like sine inverse x plus sine inverse y, cos inverse x plus minus cos inverse y, but you don't have to remember all of them. But yes, this is an important, and under different situation what we get here, that we have to remember. At least this one you should remember. Generally, questions have been asked from these only. From other conditions, questions have not been asked. So generally, we don't remember different conditions, other conditions. We just remember the formula. But for this, we remember the condition also.
So I can just once again say how we are not taking pi here.
Pi we are just not taking, because tan inverse x is 0 to pi by 2. Tan inverse y is 0 to pi by 2. So the upper limit is pi by 2 in both of them. So if you add pi by 2, you will get pi. So it will not cross pi in any situation. So that we have automatically satisfied. That in the previous one, it was greater than 0 automatically. Here it is less than pi automatically. But greater than pi by 2, we have to check, because we don't have that limit. If we add tan inverse x plus tan inverse y, this will have the minimum value 0 and maximum value pi. So the maximum value pi is already satisfied. Minimum value 0 is already satisfied. But in between pi by 2 condition, that you have to check. So I hope you have written this. Now we have a formula that tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus xy. Here just remember one condition for this xy greater than minus 1. So there are other conditions also, but it is not needed generally. So mostly it is not needed. Mostly till now it has not been needed. So you just remember this. So this is for tan inverse x minus tan inverse y. So I will give you few questions right now based on these. So if I give you a question here that if cot inverse alpha plus cot inverse beta is equal to cot inverse x, then x is equal to in terms of alpha and beta. So you just have here, don't be so much concerned about the conditions. You can directly apply the formula, but with some change, because here it is cot and you know the formula for tan. So first change it into tan and then apply. Shall I just no more in this? Okay, Sharif, are you doing it?
Yes, sir. Sir, after converting cot into tan, can you just take them? Can you take tan as common?
I couldn't get you, sir. Can you again say?
We're converting cot to tan, right? So
Yeah.
then we'll get tan minus 1 by alpha plus tan minus 1 by beta. We'll get tan minus 1 by x. Then and we take
Minus
tan
one,
minus
don't
1
call
is
it
common.
minus one, call it inverse.
But I can
Tan
speed run
inverse
it.
of 1 by alpha plus tan inverse of 1 by beta is equal to tan inverse of 1 by x. You do like this. Though it is not
Yes, sir.
always true, but it is true when x is when x, alpha beta are positive. So we are considering it to be positive here.
Then now can we take tan inverse as common?
Then you have to apply the formula which we just studied.
Yes, sir.
This will be the formula now. What was the formula? Tan inverse. X is 1 by alpha, y is 1 by beta, by 1 minus 1 by alpha into 1 by beta is equal to tan inverse of 1 by x. This is how you write it. Now you will write it as tan inverse of beta plus alpha upon alpha beta minus 1, and alpha beta will get cancelled. It is tan inverse of,
Sir, I got the answer.
sorry,
This is the answer. X is equal to alpha beta minus 1 by alpha plus beta.
yeah, correct. So we are not going into the intricacies of the conditions because in that case we will have to do so much of cases and all that. So the purpose of this question is just to find x in terms of alpha beta simply. So that we have done it. Shavaz, you quit in between. What happened?
Yes, sir. I was disconnected.
Okay, you're disconnected. Okay, so this is clear.
Sir, just one question here. Tan inverse x plus tan inverse y. There are two conditions, right? So
Yeah.
which one we should
So,
use? Like when we
so
should.
we are using the simple condition. We are not going into the details because in the question it is not given. So if in question it is not given, we'll just proceed with the simple case.
Yes, sir.
So let us discuss a question based on the concept
Sir,
of,
can you scroll up?
yeah. Generally, when question gives you a condition, then you consider that condition. And if there is no condition in the question, so you take the simple case.
Yes, sir. Finished.
So, so you have to simplify this expression tan inverse of cos x upon 1 plus sin x, where minus pi by 2 is less than equal to x is less than equal to 3 pi by 2. You might also have a test of matrices and determinants soon in 1-2 days. So just revise that also, JEE level test.
Today test is there, sir.
Sorry.
Today is there.
No, not today, after 1-2 days.
Sir, Sunday. Yes.
It will be informed to you. Because I have sent the question paper, so I think soon it will be conducted.
Sir, sir, should we calculate sine and cos?
By using trigonometric identities first, like I can give you a hint, like you can write cos x as uh, cos square x by 2 minus sine square x by 2. Okay. And 1 plus
That's
sine
the
x as,
identity of cos 2x.
sorry.
This is from the identity of cos 2x.
Yeah. So if it is cos 2x, then we use x here. If it is x here, then we use x by 2 here. It is the angle become half. In case of 2x, it becomes x. In case of x, it becomes x by 2. Similarly, 1 plus sine x is sine square x by 2 plus cos square x by 2, which becomes 1. Plus sine x can be written as 2 sine x by 2 into cos x by 2, which is sine x. So this becomes sine cos x by 2 plus sine x by 2 whole square. So the numerator which is given there, you have to write it like this. Denominator which is given there, you have to write it like this and then proceed.
How did we get cos x is equal to 1 plus sin x?
How do we get?
Cos x is equal to 1 plus sin x.
Cos x is not 1 plus sin x. 1 plus sin x is the denominator. So that 1 plus sin x, the 1 is sin square x by 2 plus cos square x by 2. This is 1. 1 you can write it like this. No? Sin square theta plus cos square theta is 1. And sin x you can write as 2 sin x by 2 into cos x by 2. That is also an identity. So what it means is that you can write this given question as tan inverse
Is the answer pi by 4 plus x by 2?
pi by 4 min. Again, can you tell me?
Pi by 4 plus x by 2.
Pi by 4 plus x by 2. I think that you are saying the correct answer. Let us see. So, in the next step, what we have done is cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. That is the identity of a square minus b square. And denominator, we keep it like this only. So this cos x by 2 plus sin x by 2, one term will get cancelled with this square. And we will get this. Then what we will do is tan inverse of cos x by 2 minus sin x by 2 by cos x by 2 plus sin x by 2. So we will divide by cos x by 2 in the numerator and denominator. So this will become 1. This will become tan x by 2. And in the denominator, cos x by 2 by cos x by 2 is 1. And sin x by 2 by cos x by 2 is tan x by 2. So this we get. I think there is a mistake of sign in your answer, because this will give you 1 is tan pi by 4 minus tan x by 2. And here it is 1 plus tan of pi by 4, because tan of pi by 4 is 1. So wherever there is 1, you can use it according to your suitability. So this will be this. So this tan A minus tan B by 1 plus tan A into tan B. So this will be tan of A minus B. Now tan inverse and tan will cancel. X by 2 it is. Okay. Now one important thing is still missing. Can you cancel tan inverse and tan? Only if in the principal value range. And the condition is given that x is between minus pi by 2 to 3 pi by 2. So x is in between pi by 2 to 3 pi by 2. This is what is given.
It's minus, right?
Minus pi by 2. So if we take x by 2, then it will be minus pi by 4 to 3 pi by 4. And when we subtract it from pi by 4, so it will become pi by 2, and it will become greater than equal to pi by 4 minus x by 2, and we will subtract pi by 4 by 3 pi by 4 by pi by 4. So when we will subtract 3 pi by 4 by pi by 4, we will get minus 2 pi by 4, which is minus pi by 2. So yes, this pi by 4 minus x by 2 is in the principal value range of tan. Even if we would not have checked, we would have got the correct answer. But generally, we must check it, because if it was not lying in the principal value range, then we can't do it like this. So this is pi by 4 minus x by 2. So this will be your answer, not plus x by 2, but it will be minus x by 2. I think minus pi by 2 and 3 pi by 2 should not be included. Anyhow, they have included it. No issue. So you can start writing from here, and you can cross check your result also from here. I'm scrolling it down a little bit. If you have any query in any step, you can surely ask.
We're gonna scroll down a little bit.
Scrolling down or up?
Down.
Done.
Yes, sir.
Okay. Let us see few more questions because most of the things are same as that of your CBSE class, but there are questions which are little different in JEE which is being asked. So some formula and all are different, which I already told you in the previous class, graphs and all. So this is a question, you have to find its value. So you should revise matrices and determinants one. I hope you may get a message about it. So
Sir,
yeah,
here you can use tan versus x plus tan versus y, right?
correct. So can we apply which condition can be applied here? Can you tell me? We had two conditions, no?
xy less than 1.
Xy less than, correct. It is 1 by 3 into 1 by 2, which is 1 by 6, which is less than 1. So we'll simply apply tan inverse of x plus y by 1 minus x into y. We need not add pi plus. If it was xy greater than 1, then we will apply pi plus tan inverse of this. So now calculate it. What this value will be finally? This value 1 by 3 plus 1 by 2 by 1 minus 1 by 2 into 1 by 2. What it would be? Just take the LCM in the numerator and denominator. It will be 2 plus 3 by 6. And here it will be 6 minus 1 by 6. So it will be 5 by 6 by 5 by 6, which will be 1. So this will be cos of tan inverse of 1. Yeah, then
5 by 4.
5 by 4, correct? Tan 5 by 4 is 1, so tan inverse 1 is 5. What is cos 5 by 4?
1 by root.
1 by root 3. This will be your answer. If I make a small change in this question, like I write here cos of tan inverse of 3 plus tan inverse of 2, not 1 by 3 and 1 by 2, 3 and 2. Then what will be the answer? Just try this out.
And now we should use that greater than one condition, right?
Yeah, it is greater than 1. So we will apply that formula.
Sir, I got 1 by root 2 again.
1 by root 2. Okay, let us see.
So is it minus 1 by root 2?
Minus 1 by root 2. Let us see. It will be cos of pi plus tan inverse of 3 plus 2 by 1 minus 3 into 2. So this is what we will do here. Now, cos of pi plus tan inverse, this will become 5 by minus 5, that is minus 1. So it is cos of pi tan inverse of minus 1, it means minus pi by 4. Minus 1, it happens at minus pi by 4. The principal value is minus pi by 2 to pi by 2. So in that region, minus pi by 4 is the angle where we get tan of minus 4, pi by 4 as minus 1. So this is cos of 3 pi by 4. Cos of 3 pi by 4 is in the second quadrant, or you can directly write from here also that it is minus cos pi by 4, and this will be minus 1 by root 2. So this will be your answer. Let us do one more question based on these concepts. It is sine inverse of 1 by root 5 plus cot inverse of 3. So what would be that equal to? So what is the hint basically? Just try to change sine inverse also into tan inverse and cot inverse also into tan inverse. So what we used to do, like sine inverse 1 by root 5 if we have, we generally take an angle theta which is sine inverse of 1 by root 5 and say that sine theta is 1 by root 5. So this is theta, this is 1, this is root 5, perpendicular and hypotenuse. Base will be root over h square minus p square, so it will be 2. So sine inverse of 1 by root 5, which is actually theta. So tan theta can be written as 1 by 2. So theta can also be written as tan inverse of 1 by 2. So theta, which is sine inverse of 1 by root 5, can also be written as tan inverse of 1 by 2. And cot inverse 3 can be written as tan inverse 1 by 3. For this also, you can do this triangle method, but this identity we already know, so we can do this. And then it is simple, this will come out to be 1. This we just did above, previous to the previous question.
There is the answer 5 by 4.
It will be, yeah, not 1, 5 by 4. Yes, sorry, 5 by 4. Tan inverse of 1, that is 5 by 4. So let us keep till here, as today the attendance is also less. Other students have not joined. I don't know what is the reason behind it, but there may be some